So here we're going to look at a reaction known as dissolving metal reduction, and we're specifically going to look at it as it pertains to alkynes. So the purpose of a dissolving metal reduction for alkynes is it lets us essentially, even though it's not a hydrogenation in that phrasing, it allows us to do essentially what is a partial hydrogenation. And specifically, it allows us to convert an alkyne into the trans, and pretty much only the transalkene. And this is one of the reasons we can say it's not really a traditional hydrogenation. Traditionally, hydrogenations, because of the way the metal interacts with the reagents, only give us cis-alkenes. So in lecture, I've most likely shown you this reaction as just the addition of either lithium or sodium metal in the presence of ammonia at low temperature, approximately -33°C. And that again gives us addition of these two hydrogens. Now, here I'm going to go into a mechanism. This is not a mechanism that I generally hold you responsible for in lecture, but we're still going to go through it so that if you're curious about it, you can see what it is. So in this mechanism, our metal, again, this could be lithium or it could be sodium. The purpose of these metals is these are metals that have a single electron, and especially in a single electron they want to get rid of, and it donates its electron to the alkyne. Notice we're using our one-headed or fishhook arrows here because we're only looking at one electron transfers. And so what we end up with is one of the carbons of what was the alkyne has a radical or an unpaired electron, and the other carbon has a negative charge. At this point, the geometry of the alkene is set, and it ends up trans. And the reason it ends up trans is these electrons that are now on carbon want to repel each other. They want to stay far apart from each other. And that's best accomplished by the trans geometry. So this anion now picks up a hydrogen from ammonia. We still have our radical here. And that radical can accept another electron from our alkali metal. That now gives us another anion, which can remove another hydrogen from ammonia and give us our alkene as the product. At this point, our reaction is done. These reaction conditions don't really react with alkenes, and so there's nothing further that happens. This reaction can take place with different types of substitution. But the one functional group you have to be careful with is you have to be careful about the presence of aromatic rings. Aromatic rings undergo a reaction known as the Birch Reduction. That's a reaction that will be covered in the aromatic chapters in this course. And the conditions for a Birch reduction are very, very similar to those for this alkyne partial reduction. And so if you use those types of conditions, the lithium and ammonia with an aromatic ring, you may find that the aromatic ring also reacts in that case. So again, this reaction, which is referred to as a dissolving metal reduction, allows us to convert alkynes specifically into the trans alkene.